Okay, in this video we're going to talk a little bit about some inverses. And first of all, I want to remind you that the word arc means inverse. So arc and inverse kind of have the same meaning there. So an arc sine question is really asking you about an inverse of sine question. So I went ahead and made some notes here about the first quadrant of our unit circle, as well as then our inverse choices for sine, tangent, and cosecant using those function restrictions. And on this one, the cosine, secant, and cotangent inverse options using those function restrictions. So if you need to pause the video and jot those down, you can do that at this time. So let me start with number 29 then. On number 29, we start by finding the arc sine of 1/2. And so again, arc sine is the same thing as an inverse. So really what they're asking me here is the inverse sine of 1/2. And remember, when we have an inverse, you want to ask yourself the question, where is sine 1/2? So we're working with a positive value. This is where my positive values are up here, and this is where my negative values are down here. Let's put positive and negative on these as well. So when I'm working with a positive value, I'm going to be in the first quadrant, and I know that sine is y, so I have a y value of 1/2 for sine at pi over 6. So my answers for our inverse questions are always going to be angles. All right, also in number 29, they ask me for the inverse cosine of negative square root of 2 over 2. So on this one, square root of 2 over 2 for cosine is happening at pi over 4, but because this is negative, I'm going to go over here into the second quadrant, and my over 4 angle in the second quadrant is going to be 3 pi over 4. So it's a little bit like some multiple choice questions. These are your only answers for a cosine, secant, or cotangent question. These are the only ones right here for sine, tangent, and cosecant. And then finally, let's find the inverse tangent on this one of 0. And so when we talk about tangent being 0, we're talking about tangent, which is y over x. So I want to know a place that has a y value of 0 and an x value of 1. And so that's going to happen right there at 0 pi. So again, with those inverses, ask yourself the question, where is the trig function, this value, on your unit circle? Okay, on number 30, we're continuing with that same idea, but now we're going to work with some inverses, like secant. So my inverse secant of 2. So rather than work with secant, I'd like to work with cosine. It's reciprocal. So really what I'm looking for here is, where is cosine 1/2? All right, I know cosine is x, and we're working in the first quadrant because that's positive. So I have an x value of 1/2 at pi over 3. All right, also on number 30, we're working with a cotangent. What you want to be careful with on cotangent questions is that we are going to work with tangent to help us find the reference angle, but then we still need to use these function restrictions right here with cotangent. So tangent and cotangent kind of split on their function restrictions. All right, so I'm looking for a place where tangent is going to be 1, because 1 over 1, if you flip it, still just 1. So I'm looking for a place where tangent is 1. Tangent is 1 right here. See if you can see that right here at pi over 4. So if I look at my cotangent function restrictions for negative, my over 4 angle over there at 3 pi over 4. So be careful of changing cotangent into tangent, because if it's negative, we have to use these function restrictions as opposed to these for tangent. So be real careful with flipping that one upside down. And then on the last one on this one, they asked me about the arc cosecant. So again, arc is the same thing as an inverse, and we're working with negative square root of 2. So I'm going to flip this upside down and use sine instead. And when I flip this upside down, I'm still going to be negative, and that's going to give me the square root of 2 over 2 when I flip that one upside down. So with sine, square root of 2 over 2 is going to be right here at pi over 4. And with sine to be negative, I'm going to drop down here into the fourth quadrant. So that's going to give me negative pi over 4. Okay, on 31, we get into a composite function with our inverses. So on 31, I want to find the exact value of the tangent of the arc cosine. I'm going to go ahead and make that the inverse cosine of 1/2. And with a composite function, you want to work from the inside out. So I'm going to start just by going over here on the side, and I'm going to find, where is cosine 1/2? All right, so back to my unit circle that I was using. We're working in the first quadrant because it's positive, and cosine is 1/2 right here at pi over 3. So So this is going to be pi over 3. So what I'm going to do is I'm going to take out the inside part, and I'm going to replace that with pi over 3. Okay, so now we're going back to using just regular unit circle, where I want to find the tangent of pi over 3. So now I've got the angle. I want to find the value, and so my tangent value at pi over 3 is the square root of 3. So always on those composite functions work from the inside out. And then finally on this video for number 32, I want to find the arc sine. So I'm going to go ahead and call that an inverse sine of the tangent of pi over 2. So this time they put the inverse on the outside and they put the value on the inside. So be very careful with that. So at pi over 2, let me go take a look at pi over 2 up here. I've got 0, 1. So my tangent value then would be 1 over 0 or undefined. So what it's asking me here is, where is sine undefined? And if you think about your graph of sine, undefined would be where you have an asymptote. And remember, the graph of sine just kind of continues to go on and on forever like this. So we never really have asymptotes on the graph of sine. Same thing this way. Okay, so I don't have a place where sine is undefined. So I'm going to say that number 32 is just not possible. Now, if it had asked me about 0, that would be a different situation. But since I'm working with that undefined there in those asymptotes, that one's not possible.